Imagine boarding a train. But not just any train. This one doesn't run on tracks. It runs on light itself, carrying us across the vastness of the universe. Our journey begins on Earth, our home, a tiny blue oasis, floating in an infinite void. But tonight, we leave it behind. The engines are warming up. The countdown has begun. 3, 2, 1. We rise above the clouds, the city lights shrinking beneath us. The world we know fades into a distant memory. The silence of space welcomes us. Our first stop, the Moon. 384,400 kilometers away. A silent world of dust and craters. The Moon has no air, no wind, no sound. This is the farthest humans have ever traveled. Yet, it's only the first step of our cosmic voyage. As we leave the Moon behind, the Earth becomes a distant blue dot, and Mars appears on the horizon. After a short leap through the void, we arrive at Mars. From a distance, it looks warm, its rusty surface glowing under the faint sun. But don't be fooled. Mars is freezing cold. The air here is thin and poisonous, made mostly of carbon dioxide. If you stood on the surface without a suit, your blood would boil and freeze at the same time. Yet Mars is a place of wonders. Towering over the landscape is Olympus Mons, a volcano 3 times the height of Mount Everest. Mars once had rivers and lakes. If life ever existed outside Earth, this might have been its home. But for now, it's a silent desert, waiting for us to return one day. But we are travelers of the cosmos. Our next destination is a place of giants, 778 million kilometers away. As we approach Jupiter, the gas giant dominates our view. It's a world of endless storms and crushing gravity. Beneath its thick clouds, winds rage at 500 kilometers per hour, and lightning 1,000 times more powerful than Earth's crackles through the sky. The Great Red Spot, a storm bigger than Earth itself, has been raging for at least 300 years. But we don't have time to stop. Beyond Jupiter lies the true edge of our home, the solar system, the Oort cloud, 15 trillion kilometers away. The sun, once so bright, is now just a dim star behind us. We've reached the Oort cloud, a vast icy graveyard of comets and frozen rocks, left over from the birth of the solar system. It's colder here than anywhere we've ever been, near absolute zero, negative 273 degrees Celsius, or negative 459 degrees Fahrenheit. Nothing moves, nothing stirs. We are on the edge of the familiar. And then, with a final push, we leave the solar system and we cross into the unknown. Interstellar space. For the first time, the sun is no longer our guiding light. At 4.24 light-years, we approach Proxima Centauri, the closest star to our own. It's a red dwarf, smaller and dimmer than the sun, but still burning at 2,700 degrees Celsius. We gaze at the lonely world, wondering, but we are still at the very beginning of our journey. Drifting further, at 7,000 light-years, we enter one of the most iconic locations in the cosmos, the Pillars of Creation, deep within the Eagle Nebula. Towering gas columns stretch into the darkness, sculpted by the radiation of newborn stars. Each pillar is several light-years tall, yet they are slowly being eroded by the same stars they helped create. Inside, young suns are forming, hidden behind thick clouds of dust. This is a cosmic nursery, a place where the next generation of stars is born. One day, these stars will shine across the galaxy, but the pillars themselves may already be gone. destroyed by a supernova thousands of years ago. We are only seeing their light from the past. If you think our sun is big, wait until you see this. At 9,500 light-years, we arrive at UY Scuti, one of the largest known stars in the universe. It's a true titan, over 1,700 times the diameter of the Sun. If it replaced the Sun in our solar system, it would swallow Mercury, Venus, Earth, and even Mars. Its surface is a seething inferno, burning at thousands of degrees, but its gravity is weak, so weak that it constantly sheds layers of gas into space. It's nearing the end of its life, a ticking time bomb. One day, it will collapse under its own weight, erupting in a supernova so powerful it could outshine an entire galaxy for weeks. And then, nothing will remain but a black hole or a neutron star. As we travel deeper into the galaxy, the stars blur into a golden haze. And at the heart of it all, we find Sagittarius A star, the supermassive black hole at the center of the Milky Way. This monster is 4 million times the mass of the Sun. Anything that gets too close is swallowed forever. Even light itself cannot escape. Time slows, space bends. We dare not go closer, or we too will be lost in the abyss. Instead, we push onward, beyond our own galaxy, into the great unknown. As we leave the supermassive black hole behind, our journey takes us beyond the Milky Way, into the large Magellanic Cloud, a satellite galaxy of our own. And here, we find one of the most breathtaking sights in the universe, the Tarantula Nebula, a vast web of glowing gas and young stars. This is one of the most active star-forming regions we know. The temperature inside its clouds can reach tens of thousands of degrees, but it's also where new suns are born. Among them, we find a monster, R136A1, the most massive star ever discovered, over 300 times the mass of our Sun. It burns so brightly that it would make our Sun look like a candle flame next to a bonfire. But its life is short. In just a few million years, it will explode in a violent supernova. For now, though, it shines like a cosmic lighthouse, lighting our way deeper into the universe. Our next stop takes us outside the Milky Way for the first time, to Andromeda, our closest galactic neighbor. At a distance of 2.5 million light-years, stretching 220,000 light-years across, this galaxy is home to 1 trillion stars. If we looked up from a planet orbiting one of its suns, the night sky would be ablaze with light. But Andromeda is not just a peaceful spiral, it's heading straight for us. In about 4.5 billion years, it will collide with the Milky Way, tearing apart stars and reshaping both galaxies into something entirely new. For now, though, it stands as a reminder. Even entire galaxies are in motion, dancing through the universe. As we travel deeper, we find something unsettling, a place where there is almost nothing. The Boaters Void is one of the largest empty regions in the universe, stretching 330 million light-years across. There are almost no galaxies here, no stars, no planets, just darkness. If we stood in the middle of it, we would see almost no light from any direction. Leaving behind the emptiness of the Boaters Void, we now enter a realm of incredible cosmic activity, the Phoenix Cluster, approximately 5.7 billion light-years from the Earth. This is one of the most massive galaxy clusters in the known universe, containing thousands of galaxies bound together by gravity. But what makes it truly fascinating is the supermassive black hole at its center, which is devouring matter at an astonishing rate. Most black holes in galaxy clusters eventually quiet down, but this one is still feeding furiously, emitting X-rays so powerful that they heat the surrounding gas to tens of millions of degrees. This energy should prevent new stars from forming. Yet here, new stars are born at a staggering pace, hundreds of times faster than in the Milky Way. It's as if the Phoenix cluster has defied the rules of the cosmos, proving that even the most chaotic places can give rise to new life. The deeper we travel, the larger the structures we encounter, and none are more mind-boggling than the Hercules Corona Borealis Great Wall. This is the largest known structure in the observable universe, a cosmic web of galaxies and galaxy clusters stretching across 10 billion light-years. To put that into perspective, if we traveled at the speed of light from one end to the other, it would take us 10 billion years, longer than the solar system has even existed. This structure is so vast that it challenges what we thought we knew about the limits of cosmic expansion. Even today, scientists struggle to explain how such an immense structure could have come together in a universe governed by gravity. Now we reach a place where time itself bends, where we are not just traveling through space, but into the distant past. Here lies GNZ 11, the most distant galaxy ever observed. Light from this galaxy has been traveling for 13.4 billion years, meaning we are seeing it as it was when the universe was just 400 million years old, less than 3% of its current age. It is a glimpse into the cosmic dawn, a time when the first galaxies were forming from clouds of primordial hydrogen. This galaxy is small compared to the Milky Way, yet it is bursting with star formation, burning brighter than we would expect for such a young system. By studying GNZ 11, we are peering into the earliest history of the universe, searching for clues about how the first structures formed in the endless void. At last, we reach the edge of the observable universe, the cosmic microwave background, CMB. This is not a place filled with stars or galaxies. It is the oldest light in existence, a faint, ghostly glow left over from the Big Bang itself. Born 380,000 years after the universe began, the CMB is the earliest image we have of the cosmos. Before this moment, the universe was a searing hot fog of plasma, so dense that light could not escape. But then, as the universe expanded, this plasma cooled, and suddenly, light could travel freely, leaving behind this faint radiation we now detect. This is the ultimate boundary of our journey, the farthest our eyes can see into the past. Beyond this, the universe continues, but its secrets remain unknown. We have traveled from Earth to the edge of the observable universe, a journey spanning 13.8 billion light-years. It makes you wonder, how small do we really seem in the face of the cosmos, and how much is still waiting to be discovered? There's always more to explore, more mysteries waiting to be uncovered. If you like this video, then subscribe for more such adventures. This is That's How. See you next time with another epic journey.